Everybody, welcome to our Facebook Live tonight. I'm just going to tell Twitter really quick that we are on, and we will get started in just a minute. All right, we are almost ready to start our Facebook Live tonight. I'd like to welcome everybody coming out. And I'm just telling Twitter. All right, just told Twitter. And now we'll tell Instagram really fast. Maybe. We'll tell Instagram in a minute. To our Facebook Live tonight. I don't want that going on my phone. Well, now you can tell how good or not good I am. I'm trying to just copy the link. I think I may have just given up on Instagram. We will get Instagram in a minute. Cool. So tonight we are going to talk about one of my, whoa, we're not getting focused very well there. Come on, camera. There we go. We're going to talk about one of my favorite math teaching strategies that I think is the most underutilized. Maybe not the most, but for sure underutilized. Maybe because we don't often know this particular strategy. I can tell Instagram now. Give me just a second. And nope, that's not what I wanted to do. I'm going to have to go copy that again. I am technologically adept tonight or something. All right, almost there. Wow, it is not letting me do that. Why won't it let me copy and paste? All right, somebody's going to have to teach me how to be technologically adept more than I am at the moment because I thought I was doing a pretty good job. Yeah, all right. Instagram will have to see it not live. And why is that not focusing? I wonder if it's because that stupid whiteboard. There, see, now we're focused. Okay, I'm going to have to be in the middle or something. All right, one of the most cool math teaching strategies in two ways. So we're going to talk about both a way of teaching something really cool and the thing itself that's really cool. Tonight, I want to emphasize and exemplify and let you guys experience the over strategy with all four operations. Again, really powerful and really cool, and it is the over strategy. If you'll hang around to the end of the Facebook Live, I think this is going to go about 40-45 minutes tonight. I'm going to give away a freebie that shows the over strategy and has lots of examples. So hang around for that. If you wouldn't mind liking the post itself and following the page, that will help more people find it, and we would appreciate that if you're up for that. Cool. Welcome. I see a few people are joining. Kim, welcome. Holly, welcome. Jenny, it's been a while since I've seen you. Welcome. Glad to have you guys on. Okay, so I'm just going to jump right off, and I'm going to suggest that there's a problem. Whoa, my camera's making me crazy. Stop doing that. I don't know how to change it. Okay, sit right in the middle. In a minute, okay. I hope that'll work. Anyway, so I'm going to launch a problem right now that I want you to think about, and by the end of the Facebook Live, I'm going to ask you how you would solve it. So maybe don't spend a lot of time solving it right now. I mean, you could if you want to, but you might miss some other things. So let me just tell you that at the end, I'm going to ask you to solve 2,475 divided by 25. And we're going to do that mentally, and it's going to be really cool. All right, so here we go. The first thing I'd like to do is talk about that one of my favorite teaching strategies ever is called problem strings. It's an instructional routine. If you're secondary, that's okay. You haven't really probably heard of it because we don't typically do instructional routines at the secondary level, but we could because there's some really good ones. It's called a problem string, a string or series of problems. And tonight I'm going to use problem strings, one of my favorite techniques for teaching math, to teach one of my favorite strategies, math strategies, the over strategy. All right, to do that, we're going to kick right off and we're going to do an addition problem. So the very first problem of tonight, you like my little whiteboard back here? Very first problem of tonight is 7 plus 30. So I'm just going to write that. We're just thinking about 7 plus 30. And that's not hard. Everybody knows that's just 37. But I'm going to go ahead and model that quickly, like 7, and I'm going to add 30. And then you guys just know that's just 37. So I'll just throw that down there. Now, if I was doing this with kids, I would pause a little bit. I would wait until I would ask them. I'm not going to really be looking in the comments or anything for answers until we get to a certain point. So go ahead and be thinking. You're welcome to throw your answers out if you want on the, to post them in a comment. You can. I probably won't be looking at the comments too much until I ask some important questions as we go. So the next question I'm going to ask you is, could you use the problem that we just have up here to help you think about 7 plus 29? 7 plus 29. Oh, do you think that might help? Thank you, Trish. We're glad Trish is here with us tonight. Could I use 7 plus 30 to help me think about 7 plus 29? I don't know if that helped.
Maybe not.
Yeah, but I kind of like it where I'm not quite as... yeah, anyway, moving on. So did anybody think about 7 plus 30 is 37? Is 7 plus a little bit less? Just almost not quite as much? Is that just one more back? Is that just 36? Could I use that to help me think and reason? Sure enough. All right, what if I gave you a problem like 14 plus 60? Not hard, right? We can do that. 14 plus 60. That's easy. That's just 74. Cool. Anybody want to guess what the next question is? Could it be 14 plus 58? Ha! Gotcha. You were thinking 59, which would have been a fine problem, but we can get even better than that. Could we think about 14 plus 58? Just 2 less? What is 2 less than 74? Just that 2 less than 74? Sure enough, 72. Cool. Is that right? Huh. Interesting. Next problem. What if I asked you about 4.8? Yeah, it's decimals. Hang in there. We can do it. 4.8 plus 4? $4.80 plus $4. That's not bad. Is that just $8.80? Right? So then can I ask you, what is 4.8 plus 3.9? Dun, dun, dun. If 4.8 plus 4, and I wish I would have written this when I did the first problem, is 8.8. Then can I think about 4.8 plus 3.9? It's just a little bit less. How much less? Just a tenth less? What is a tenth less from 8.8? 8.7. Sure enough. Check it out. We've just done some relatively interesting addition, thinking and reasoning, using a little bit too much, and then we have to back up just a little bit. We just adjust back just a little bit. Cool. How about if I gave you then, so we just did a helper to do a harder problem. A helper to do a harder problem. And a helper to do a harder problem. What if I don't give you the helper? Could you come up with a helper for this sort of over, and then I have to just adjust? What if I give you a problem like 36 plus 19? What do you got? What could your helper be for 36 plus 19? Now I'm looking in the comments. 36 plus 19, what could a helper be? And now I'm wondering if Facebook Live is Australia. We got people from Australia and Ontario. Woo! Hey, Annalise, how's it going? There's a reflection on the whiteboard. Oh, nice. Thanks, Jenny. I appreciate that. Does it look better now? Maybe tell me. So I'm not seeing any more comments in time. I don't know. Sometimes Facebook Live has this little bit of a delay, so maybe I won't wait too much longer. But I wonder if anybody's thinking about 36 plus 20. Could I use 36 plus 20 to help me think about 36 plus 19? If 36 plus 20 is 56, what's 36 plus 19? Just back up just a little bit. How much? Just one. What's one back from 55? 56. What do you think? That's the over strategy for addition. There we go. Cool. I wonder, look, nice. Now I can see your comments. They're coming through. So I probably maybe I'm learning how to use Facebook. I will try to do better at looking at your comments. I think I just need to just scroll up. Oops. All right, cool. So that could be the addition strategy over, like the over strategy for addition. Add a bit too much. Back up. Hey, do you think we could do the same thing for subtraction? Dun, dun, dun. So give me just a minute. So while I'm erasing, think about maybe a subtraction problem that you think might work for an over subtraction strategy. Let's kick it off. What if I asked you 47 minus 10? This is not difficult. $37? What do you think? 47 minus 9? Could we use the problem before to help us think about 47 minus a little bit less? How much less? Just one less? If that's 37, then I jumped smaller. So is that 38? What do you think? We just used a subtraction problem we know, starting too far, so I have to adjust back. If I subtract too much, then I have to adjust back because I've taken away too much. I don't want to take away that much, so I'm going to give you a little bit more back. What if I gave you a problem like 62 minus 20? Oh. Just 42? How about 62 minus 18? Are you seeing a pattern to the problem strings? How long will the jump of 18 be? Longer than the jump of 20? Shorter than the jump of 20? Shorter than the jump of 20, yeah? What do you think about the idea that I can do 62 minus 20? Oh, but I didn't really mean to subtract that much, and just adjust back to minus 18. Cool. How about another one? What if I asked you 85 minus 20? Not hard, right? 65? Can we still see that? Yeah, okay, cool. 85 minus 20? You're telling me that's just 65? Oh, shoot, I was supposed to write. How about 85 minus 19? Anybody just like right away, almost just sort of see it up there? It's just that one little 66? Cool. So again, I've given you a helper to do the clunker. A helper to do the clunker. A helper to do the clunker. What if I give you this for a clunker? What if the clunker is 72 minus 49? What helper could you use to help you think about 72 minus 49? All right, I'm going to see if I can get better at the... Hey, my mom's on! Hi, Mom! That's pretty cool. Fun. So let's see. I'm looking for helpers. Now we'll see. I am scrolling. I'm not going to wait too long to see. What would your helper be? While you guys are throwing in helpers, let's see if I recognize anyone else's name. Oh, man, we have that Cyrillic name. I really want to know how to pronounce your name. I have to ask my husband. He speaks Russian a little bit. I bet he could pronounce that, or at least try to, how you pronounce in Russian. So Jenny's on. Trish is on. Hi, Brian and or Tammy, one of the two. Hi, Jig. Welcome. Laura Lopshire. Great. Glad to have you on. Okay, cool. Hey, minus 50. Absolutely. So could I do 72 minus 50? Sure enough. That's just 22. But I only want to subtract 49. Cool. And we've just solved 72 minus 4. Oh, help me. I can erase. Right? Okay, cool. This is the over strategy for subtraction. We can think and reason using numbers that we know, some pleasant, friendly, happy numbers that to subtract a bit too much, and then we can just adjust. It's the over strategy for subtraction. This only works for addition and subtraction, right? There's no way that it would actually work for multiplication. I want you to think about that for a minute. What do you think the over strategy might look like for multiplication? There it is. Oh, before I go on, and you're thinking, sorry. As you look at this, this is an example of a problem string, a string or series of problems in a certain order intended to create relationships in the learner's head so that models, strategies, and big ideas become natural outcomes. This is my favorite teaching strategy. And tonight we're learning the math strategy for the over strategy. Hey, if you don't mind liking this post, that'd be great. That will help more people see it. And if you follow the page, you'll be able to see the replay. And you'll also be able to see when I do next week's Facebook Live. And we'll be doing a part 2 of our facts Facebook Live coming up soon. So if you want to be notified about all of those, follow the page. And if you wouldn't mind liking the post, that would be great. Thanks. Glad to have everybody joining. Caroline was my high school student. Woo! And I am not old. Anyway, Caroline, it's great to have you on. Okay, so multiplication, the over strategy with multiplication. We actually might make this in 45 minutes. Maybe even 40. Woo! We are going. Okay, could we think about the problem 10 times 5? Not hard. That's just 50. Oh, that's not a 10 by 5. That's not a rectangle. That's close enough. That 10 by 5, you said the area is 50. Cool. Could that help me think about 9 5s? I'm kind of wishing I would have paused on the 10 times 5 just a little bit. Where are the 10 5s in this drawing? I've got a 10 by 5. Where are the groups of 5? If I draw this right here, are there 5? 1, 2, 3, 4, 5. Sure enough, there's 5 there. If I were to draw down here, that would be 10. So the groups of 5 are these rows right here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last, that 10th one right down there. That 10th one's right down at the bottom. So then what if I only want to think about 9 groups of 5? Could I take that off? What would 9 groups of 5 left? 50 minus that 1 group of 5, does that just leave us with 45? Now, I know I'm taking a minute to do this, but I want to make sure that we sort of have a good handle on kind of the relationships. If I just get rid of that little group of 5, then I have 1 less group of 5 instead of 10 5s. So easy to find, happy, friendly number. We just have 9 5s. Now, maybe kids know 9 5s, but this could be sort of an entry problem that we could use. Then what if I were to ask kids, hey, for the next one, I wonder, before I go on, so sorry. Could you see how this is a little bit of an over strategy for multiplication? I find a few too many 5s, 10 5s, so pleasant, so that I can just get rid of those and just have 9 5s, a little bit of an over. I'm backing up again. See how these are all kind of related to each other? So again, next problem, 100 times 22. That's a big number, but it's also a really pleasant number, right? 122s, is that just 22 hundreds? Cool. Not drawn to scale. Anybody want to guess the next problem? What if I were to ask you for 99 22s? Where are the groups of 22s? Would that be a group of 22? 22, and I would have 100 of them? So what if I want to get rid of just one of those groups of 22? What is 2200 minus 22? Now, at this point, we might be a little bit like, I don't know if I can do that subtraction. So let's think about the subtraction. Could we just do this some subtraction that we know? What about 2200 minus 20? 2200 minus 20? I have to think a little bit about that one, but is that just 2180? Is that right? 2180 and 20, that would get me back to 2200. Okay, cool. And then I just need to subtract two more. What is 2180 minus 2? Cool. And we just did double-digit multiplication in about 3 steps, right? Like we could think about now some of you right now are like, Pam, this won't work for all numbers. Didn't say it did. Not suggesting it works for all numbers, but boy, the ones it does, why not? Like this is what mathematicians do. When mathematicians solve problems, they use what they know. They use relationships and connections they own to solve problems. And it just so happens that the over strategy is so brilliant in some cases. Honestly, in many cases, if you talk to somebody who considers themselves sort of naturally mathy, I think we're all naturally mathy, but maybe somebody who kind of developed relationships on their own, often they have developed the over strategy, and they will think about something like 99 22s. That's 100 22s. Just get rid of 1 22. Let's do another example. I'm going to back up a little bit again. We already used an over strategy to help us think about 9 times 5. So we know that's 45. Could that help me think about, I got to remember, 95s? We're not going to talk about the times 10 things tonight, but there's this lovely times 10 thing that we have in our number system. So if we scale up a factor times 10, then we also scale the product times 10. And we get this nice 450. Anybody want to guess what the next problem is? Would it be 89 times 5? If I know 95s, could that help me think about 89 5s? Oh, and subtracting 5 is so easy. What's 450 minus 5? Sure enough. No way that could be that easy. No way, right? Or, and I don't want to say easy to say that math is easy. I really want to say more that math is figure-outable, that it's pretty darn figure-outable to think about 89 5s as 95s, easy, figure-outable, to then just get one less 5. Not bad. All right, here we go. I gave you a helper to find the hard one. Helper to find the hard one. Couple helpers to find the hard one. Here's the last one. Ready? What if I asked you 99 49s? Dun, dun, dun. And I wonder if you can employ both the over multiplication strategy and the over subtraction strategy in one problem. All right, so I'm going to give you a second to think about that, letting everybody think. Karen Camp, how you doing? Glad to have you on. My mom said hi. Beth, glad to have you. Cindy, glad to have you. Lisa, glad to have you. Jennifer, excellent. Thanks for responding, you guys. Glad everybody's on. And hey, we have almost 60 people on tonight. That is fabulous, especially since I don't think I advertise this very well. I would welcome you guys to help me sort of get the word out. If you think this is fun, which I think it's fun, if you think it's fun, I'm going to be doing some of these as we go. For sure, one next week. We're going to do another one on how to help kids with their multiplication facts. Part 2, we did part 1 last week. We're going to do part 2 coming up. If you could like this post and follow the page and tell your friends about it, it would be great. Also, if you hang around to the end, there'll be a free resource that we'll be giving out. All right, I'm scrolling. Linda thinks we could use 149s. Let's think about that. Do we know what 149s? Well, I'd rather think about it as 4,900. There's even the answer, right? So if 149s is 4,900, what do I need? One less 49? Okay, Can we do that? 4,900 minus 49. Can we do the over subtraction strategy? Dun, dun, dun. I think we can. Yeah? Okay, so here we go. 4,900 minus 50. What's 4,900 minus 50? Is that 4,850? I know I'm going kind of fast. Sorry. But yeah? Yeah? But I subtracted a bit too much. I didn't need to jump that far. I jumped 50. I only want to jump 49. Just a little bit less. How much less? One more. Here's the hard part. The hard part. What is 4,850 and 1? Could that really be the answer to that double-digit multiplication problem, 99 49s? I hope I got it right. I'm doing this live, so you guys all be patient with me. I'm looking at what some of you guys said. Yeah, cool. Hey, Karen, don't give away the answers too soon in the chat. You wait till we do it all together, okay? Karen is a veteran of our math strat chat that we do on Wednesday nights on Twitter and Facebook and Instagram, and she's been doing lots of nice mental strategies with us. If you want to become Karen when you grow up, which kind of I do, then you could also join us on Math Strat Chat and learn some of these strategies. All right, you guys, what do you think of the over multiplication strategy? I mean, kind of powerful. If you're kind of the advanced user tonight, you might be thinking right now about what kinds of problems, if I were to ask you to generalize, what kind of problems are really, really good for the over strategy? Alternatively, what kind of problems aren't so good for the over strategy? And then we need to have one of the other 4 major multiplication strategies to be able to solve all problems that are reasonable to solve without a calculator. But check out how nice this one is for a certain set of problems. When I work with students, I will often ask that sort of extension question to kind of keep these guys flying. When I've got these guys solving the problem, they're working hard, these guys, I can kind of start to ask them to generalize. Now, eventually, I'm going to ask these guys to generalize as well. But while they're kind of still learning the strategy, I'm going to ask these guys, like, what kind of problems is this strategy really good for, this over strategy? What kind of problems isn't it good for? I'd be curious to see what... no problem, Karen. I'd be curious to see what Karen and some of my other experts might put in the chat about how they might generalize what kinds of problems this is really good for and what kind of problems it's not really good for. If you guys want to start generalizing that, you're welcome to. Maybe at a point where you're sort of getting bored. Sarah Hempel, one of my favorite teachers ever. One of my, she's on my team. She's amazing. Anyway, glad to have everybody. Okay, so we've done the over strategy for addition. We did the over strategy for subtraction. We did the over strategy for multiplication. There's no way this would work for division, right? Here we go. Division. What are you guys thinking about? What kind of numbers do you think might be nice for the over strategy for division? Here we go. Let's start with a problem like 120 divided by 6. Now, I can write it like that. I could have written it like, it doesn't really matter how I write it. I could have written it like, I need students to recognize that all 3 of those mean something about multiplicative reasoning, that there are 2 factors and a product, or a dividend and a quotient and a divisor, and the relationships between all of them, and that there's something multiplicative happening here, and then I want them thinking and reasoning. Now, I chose a problem on purpose that I didn't think, that I thought would be accessible to y'all tonight. I thought maybe we could start with 120 divided by 6. If it's not quite, let me back up a second. I might use 12 divided by 6. So you might be thinking, oh, well, I know 12 divided by 6. That's just 2. And so if 12 divided by 6 is 2, then 120 divided by 6 is 20. Does that make sense? I can think about 6 times 2 is 12. 6 times 20 is 120. All that makes sense? Cool. Could I use that to help me think about 114 divided by 6? If we know there are 20 6s in 120, and now we only have 114, how many 6s? And I'm just realizing that I didn't do a good job with a model. So pause. Could I think about this problem 120 divided by 6 as the area of a rectangle is 120. So it's like I have a rectangle and I'm trying to find the area of that rectangle. Come on, focus. My camera tonight, it is on one. Focus. Come on. Come on. Seriously. Now is it? No. Ah! Better? No. Oh, it's making me mad. Why is it not? Sorry. Okay, somebody's going to totally send me a message. There it goes. Somebody's going to send me a message and say, quit messing around with your camera. I'm sorry. It's just making me nuts when it's all blurry. Okay, cool. So could I think about a rectangle that has an area of 120, but it's a 6 by something is 120? Ooh, then it wouldn't be this tall. We know that a 6 by 20 is 120. Cool. Now I'm asking, what if the area was only 114? How are these two related? How is 120 and 114 related? A group of 6? So I need one last. This is a group of 6. Oh, that's not going to be the right color. Group of 6. Group of 6. 20 groups of 6. Here's the 19th group of 6. There's the 20th group of 6. But now I only need 114. The whole area. The whole area was 120, but I only want 114. I need 6 less. Get rid of that one group of 6. When I get rid of that one group of 6, now what are the dimensions of the rectangle? Still 6 by 19? What do you think? The division strategy for, the over strategy for division. Let's try another one. What if I asked you 220 divided by 22? Now, if I needed to, I could have asked y'all 22 divided by 22, which is 1. So then 220 divided by 22. Can we do that's 10? I know I'm using some relationships times 10. So if I was really working with students, and if I have any students on, I would definitely have done a lot of work with times 10 and divided by 10 before I would do this particular problem string. But I think I'm dealing mostly with adults on Facebook Live. Actually, you can let me know at some point. I'd be curious to see who's listening so that I can kind of judge the audience the best. So if we can think about 220 divided by 22 as 10, where's the area, where are the dimensions? Am I kind of asking about a rectangle that has one dimension of 22? I don't know the other dimension, and the area is 220, but we've answered it already, and we said it's by 10. So 22 by 10, gives me an area of 220. Yeah, so that's that rectangle. Cool. Could I use that to help me think about $198 divided by 22? How are those related? What's the area now? Only 198. There's a group of 10. There's a group of 10. Whoa. Yeah, right? No. I want groups of 22. That is a group of 10. There's a group of 22. There's a group of 22. And I don't need 220 anymore. I only need 198. Can I get rid of one group? No. Yes. One group of 22. I had 10 groups of 22. So now I only have 9 groups of 22. What do you think? Could I really think about 220 divided by 22? Or excuse me, 119? No. 198 divided by 22? Could I think about Those relationships? Cool. Ah, Kim, I'm glad you like the picture. Sweet. Robin, you know what? I hadn't either. I hadn't thought about the over strategy with any of the operations, but how cool is it to be able to think about division just a little bit over, like using a problem that we know? All right, what if I asked you 1,200 divided by 12? 1,200 divided by 12. 12 times what is 1,200? 100? Anybody want to guess what the next problem is? Some of you that know me know that I love this question. I like to ask kids this question. What is... Oh. $11.88 divided by 12. I didn't draw the picture this time. We could. I need less area, right? I've got a 12 by something. What do I know about 12s? What do I know about 12s? Well, we said that 12 hundreds is 1,200. But how many 12s do I need if I only have 1188? How is 1188, 1,188, related to 1,200? 112? Just 112? Bam! There we have the over strategy for division. Sweet. Okay, I started the Facebook Live with this question. 2,475 divided by 25. What would be your helper problem if we wanted a really nice helper problem that was just a little over? Just a little over. Just a little over. And I'm looking at what you guys are saying. Caroline, nice. Amy, exactly. Just 12 less, yeah? I like it. That was on the problem before. So 2,475 divided by 25. What are you guys thinking about? What would your helper problem be? I'm looking. Do you think I could use 2,500? Is 2,500 pretty close to 2,475? So do we know what 2,500 divided by 25 is? Well, we might have to think about that a little bit. 25 times what is 2,500? Is that just 100? Now, I may have given you some problems where you're like, this is too easy. Tonight, we're in a Facebook Live. So I definitely chose some problems that I felt like we could hang on to, that we could be able to sort of really see the over strategy. But once I get used to the over strategy and I get used to looking for numbers that are nice that I can deal with, I don't know, when I gave you this problem at the beginning, maybe some of you guys on here have enough numeracy and you're mathematizing enough that you think to yourself, what do I know? When I was in school, the gig was sort of, when I looked at this problem, I memorized what that told me to do. And I did a bunch of steps that my teacher told me to do. What I didn't do was ask myself, what do I know? Do I know something close to 2,475? Well, if I do, and it's 2,500, then bam, I can solve it. Consider, if you would, if I were to try to solve that with the traditional algorithm, which I don't think is a particularly helpful thing to teach kids, 25 goes into 2, 25 goes into 24, 25 goes into 247? I'm sure it does. And now the kids are trying to figure out, and they're doing 25 times things over on the side, and they're doing 15 of those, and they're getting most of them wrong. And I haven't even written anything down yet. But if I'm thinking and reasoning, this problem could be very doable. So again, just like I mentioned before, the over strategy isn't brilliant for all problems. There are several strategies. In fact, get my hand on there. Oh, look, I erased with my finger. Yuck. I think there's about 5 major division strategies that kids need to own. And if they own those division strategies, then they can solve any problem that's reasonable to solve without a calculator. The over strategy is one of them. One of those major strategies is the over strategy. And unlike all of the other strategies, it permeates all 4 operations. There are strategies in each of the operations that are related to strategies in another operation. But the over strategy is just so like, it's brilliant in all 4 operations. And I kind of hope that as we sort of did these problem strings tonight, my favorite instructional routine, my favorite way of teaching math, you got a feel for one of my favorite numeracy strategies, my favorite math strategies, the over strategy. Cool. If you like what you've seen tonight and you're interested to see more, you can follow my page, and definitely when we do more Facebook Lives, you'll know about it. But also, so I'm doing one next Tuesday night. Love to have you join us. But also, I am doing a free webinar. It'll be a little bit more polished. I'll have some slides I can show. I can't show slides on Facebook. Not a lot of slides. I'm not a big slide. Like, I'm not going to bore you. No, I'm not going to bore you. Yeah, it's a wonderful webinar. And are you ready? It is on one of the questions that I hear the most often from teachers. How do we help kids with word problems? I have some answers. I have some things that I really think can help you with word problems. So we're going to put in the text window how you can get to that webinar. You do need to register for the webinar. You need to save your seat. Give me just a second and I will throw that link. No, come on, Pam. Come on, Pam. Come on, Pam. I can do it. I can do it. I can do it. I am technologically adept. So if you want to register for the webinar, oh, I'm so close. Maybe Sue's on me. She might beat me to it. Here we go. I'm just going to stop talking. There we go. So that link right there will get you to register for the webinar so you can save your seat. We'd love to have you join us. And then also, if I could, talk to you briefly about, so I really, really believe that we can change the way that we teach math. I really believe that all of us can become more like mathematicians. But there's only one of me, and I've been trying to do workshops around the country. I've been teaching teachers around the world about how we can really mathematize. And in order to get that word out, one thing is I'm doing Facebook Lives. Another is we're doing the webinar. I'd love to have you sign up for it. Another, the Facebook Lives and the webinars are more of the 20,000 foot view. It's sort of like, let me give you the big picture and then let you run with it. If you want more of the on the ground, like really day to day, and you teach middle school or 5th, 6th, or 7th grade, I have an online workshop that I think you might be interested in. We have several people that are just finishing taking it the first round, and the comments are amazing. I was really hoping that I just put the link in the chat. I was really hoping that this online workshop would be, kind of good enough, because I really believe in in-person live mentoring and teaching. I really believe that's the best way to do things. But I am also aware that I want to get the word out. And so I've created this online workshop. Y'all, I'm getting comments back from people that it's actually better than live in some ways because you can go at your own pace and you have access to it for an entire semester. So you can actually try things in your class and come back and ask me questions. You can get feedback as you're trying the different things in your class. So it's all about building proportional reasoning. It really is focused towards middle school teachers. For all the rest of you, I'm also creating a multiplicative reasoning workshop that will be all about thinking and reasoning multiplicatively. That'll launch next school year. So for those of you that are interested, there are definitely ways that you can build your own numeracy and get on the ground help for teaching and reasoning. I forgot to turn my notifications off, so there's a chance you're hearing those pings come in. I will put on my list of things to do next time to turn my notifications off. Those pings mean you guys are downloading that free resource. I'm so excited that you are. The free resource, I did put that in there, right? Yes, I did. So, right? Or did I? Oh, golly. Now I'm not even sure I did. Have I put the free resource in there? Let me make sure I put the free resource in there. I don't think I have. And so now I have to think about how I know where that is. I do know. I'm so good at this. I'm just scary good at this. I'm almost there. I'm so close. Here it is. Here it is. I am about to put the link for the free resource. Thank you for hanging around. It's almost like I planned you had to hang around this long in order to get it. Oh, there it goes. Okay, so we've got the guide for the over strategy. That's a free resource, totally. The good news is once you download it, you'll be on my email list, and then you can just, there's a lot of learning that happens in my email list. Love to have you there. I am looking in the chat window just to see if there might happen to be any questions that I can answer. We are right up against the 45-minute mark. Woo! That's what I was aiming for, so I'm pretty excited that we actually got there. But I will hang around and answer questions for just a couple minutes if anybody throws one in there that you are interested. where do we find the workshop link? So the workshop link is this one. I'll put it in there again. So it was just above you. Here is the workshop link. Oh, thing to know is you can't register for the workshop until, golly, a couple weeks from now. I think the 24th or 25th is when the cart opens. But if you'll go to that page, you can get on the wait list, and we will let you know as soon as registration opens, so you can get your seat right away. So just know that we haven't quite opened cart on that. It'll you'll be able to register for it for about 2.5 weeks as soon as we open the cart on January 25th. So I'd love to have you there. That's also when the webinars are. The webinars are the 24th and 25th, totally free. You just sign up to reserve your seat. Love to have you, where we're going to attack word problems and how to help students really understand word problems. And next week's Facebook Live is all about how to use the best way to use 20 minutes a week to catch your kids up. If you got kids that have holes and you need to sort of shore them up, the best way you can use 20 minutes a week to sort of fill in some of those gaps. All right, I'm going to look and see if I see any other questions I can answer. Lynn, you're welcome. Thanks for coming. Kim, so glad you could join us tonight. What problem string should we begin with for the first year of school? Foundation in South Australia. Welcome, Australia. So glad that you're here. Golly, it depends on the grade level that you teach. So I'm thinking foundation. That sounds like a high school class. Honestly, I like to do 99 plus anything. So sort of the over addition strategy. That sometimes like really fakes kids out. They're like, whoa, you can think about addition, and you just kind of get them thinking and reasoning a little bit. You might also start with the over multiplication strategy. I think that's a nice one that kids, again, just get a really big bang for the buck. I did post the link for the resource. That is the one that is, it says download the guide for the over strategy a little bit up there. I'll put it in there one more time, maybe. I'm so technologically adept. So there's the link for the free resource one more time. You're welcome. You're welcome. Thanks you guys for joining. Appreciate that. And Annalise, she mentioned 5 strategies. Will you do another Facebook Live to explore those other strategies? Annalise, maybe. That is in the brand new book that I'm writing that won't be out for a little while, where I'm going to detail all of those strategies. But sure, we can do a Facebook Live and just give you a taste for what those are. Absolutely. I'll give a ping to Christina Tonevald's. She has a membership site. I did in the fall, Christina does a wonderful, kind of fall, I think it's August. She does a wonderful free professional development conference online. And so you can just watch it from your computer, totally free. You have access to it for a whole week. I always do a session for her. I appreciate her inviting me. It's a lot of fun. Last year's session was all about the multiplication strategies. And so if you were to join her membership, you'd have access to that. Or maybe just look for Christina Tonevald as Build Math Minds. If you look for her website, you can get on the wait list for that free conference. And then I'll do something equally as exciting this summer for it. It's every year for her conference, I roll out something new. So that's kind of a thing to know. Hey guys, great. We are done for the evening. Thank you, Trish, for translating. Interpreting. I really appreciate for all of our deaf friends out there that are listening. Super glad that you could join us, and love to see you on Facebook. Oh, anybody still around, you can feel free to join our brand new teacher group on Facebook, or if you're a parent, you can join our parent group on Facebook. Both of those have some great resources and helps for both teachers and parents, because I believe that math is figure outable. All right, y'all, have a great evening. Bye-bye.